Hello everyone, welcome to the problem set 2 of the lecture series Signals and System. So in this video we will be solving some questions taken from the book back exercises of chapter 2 of the book Signals and System by Alan V. Oppenheim, and also finally we will be solving some previous year gate questions. So question number 1. Let h of t equal to e power 2t u of minus t plus 4 plus e power minus 2t u of t minus 5. So determine a and b such that h of t minus tau. So t minus tau is one process while we are doing the convolution, right? So h of t minus tau is given as e power minus 2 into t minus tau for tau less than a, 0 for tau between a and b, and e power 2 into t minus tau for tau greater than b. So first let us see how h of t looks like. So h of t is nothing but e power 2t u of minus t plus 4 plus e power minus 2t u of t minus 5. So if we try to plot it, so let's represent this by a red signal and this by a black one. So how does this signal look like? So it is u of minus t plus 4. So minus t plus 4 greater than 0. Only in this region the signal exists. So t should be less than 4, right? So this signal exists inside this region, somewhere here. So this signal is something like here, right? This is 0, let's say. And what about this signal? U of t minus 5. This exists for t minus 5 greater than 0, which means for t greater than 5. So this signal is like something like this, right? And since it is an exponential signal, this will be a falling exponent. And this black one will be again a falling exponent. So it starts from e power minus 10 and falls. And this one starts from e power 8 and then falls in the left hand side. Okay. So now we know how to perform h of t minus tau, right? We just need to flip the signal, take the time reversal and shift it to the right by t units. So if we take the time reversal, what will we get? H of minus tau. So we will get, this is minus 4 and 5, right? So since this is e power minus 10, this will actually be smaller, power minus 10, and e power 8. Here also it will be smaller. Okay, then we need to just shift it by t units. So h of t minus tau. So the red one will actually be shifted to what will this be? This will be t minus 4. And the black one will be t minus 5. So this is minus 5, right? Okay. And this ones also will vary accordingly. Right? This one will be same. So this will still be e power minus 10. And this will be e power 8. So now from the graph only you can easily interpret. So tau less than a, it is e power minus 2 into t minus tau, right? So what will be a here? You can see a will be t minus 5. And between t minus 5 and t minus 4, it is actually 0, right? As the second condition states. And for tau greater than b, it is e power 2 into t minus tau, right? So b will be t minus 4. So this one we saw graphically. So now let us also see what happens to the equations, right? So we will just find h of t minus tau directly from h of t. So we have h of t here. It will be just replacing t with t minus tau. So 2 into t minus tau u of minus t plus tau plus 4, right? Because of the bracket I have evaluated directly, plus e power minus 2 into t minus tau u of t minus tau minus pi. So now you can see where each of these signal exists. So where this exists for minus t plus tau plus 4 greater than 0. So this means tau is greater than t minus 4. And where does this signal exist? This exists for t minus tau minus 5 greater than 0, which is nothing but tau is less than t minus 5. So for tau greater than t minus 4, so h of t minus tau is nothing but e power 2 into t minus tau for tau greater than t minus 4. And in between t minus 4 and t minus 5, both of the signals not existing, right? So it is 0 for tau in between t minus 5 less than tau, right? And less than t minus 4. And for tau less than t minus 5, it is actually this signal, e power minus 2 into t minus tau for tau less than t minus 5. And I think in the question it is just opposite. So we first have e power minus 2 into t minus tau. So we'll just reposition them. This will be minus, this will be t minus 5 greater than t minus 4, and this is 2t minus 2. Okay. From this you can directly identify A and B. So these are the answers. Okay. So we can approach any way, either the mathematical way or the graphical way, whichever is convenient and as per the question. So the second question, determine and sketch the convolution of the following two signals. Okay. So x of t is given as t plus 1 for 0 to 1 and 2 minus t for 1 to 2, and it is 0 everywhere else. And h of t is actually delta of t plus 2. It is like sum of two impulses. So we'll just draw here x of t first. So from 0 to 1 and then to 2. 0 to 1 it is t plus 1, meaning at 0 it is 1, right? Or close to 0 it is 1, and then it has a slope of 1. So here at 1 it will reach a value of 2, right? And then from 1 to 2 it is 2 minus t. So what is its value at 1? It is 1. So it is value is 1 at 1. So it is actually discontinuity here. And then at 2, 2 minus 2 we get 0. And it has a slope of minus 1. So it drops linearly to 0. And then it is 0 everywhere else. So this is the function. So again you can approach this question in two ways. You can directly do the mathematical formulation where x of t convolved with h of t, you can just write it mathematically. So this will be x of t plus 2 into x of t plus 1. Or you can also do it graphically. So in graphically you can use this property of convolution, right? Distributive property. So what it states, x of t convolved with h1 of t plus h2 of t is equal to x of t convolved with h1 of t plus x of t convolved with h2 of t. So let's take y of t is nothing but x of t convolved with h of t, right? So if we take this is h1 and h2, then x of t will be x of t convolved with h1 of t plus x of t convolved with h2 of t, right? And h1 of t is nothing but delta of t plus 2. So this is x of t convolved with delta of t plus 2 plus x of t convolved with 2 delta of t plus 1. So we know delta of t plus 2 is just a shift, right? Shifting type of property. So this is directly we can write it as this is x of t plus 2 plus 2 into this 2 factor is there, x of t plus 1. So now what we are going to do is, graphically, we are going to find x of t plus 2 and x of t plus 1 and then going to add them in this way. Okay. So let's find x of t plus 2. It is just left shift by 2 units. So it starts from minus 2, minus 1, 0. So it starts at 1, goes to 2, drops back to 1 and then drops back to 0. This is 1 and this is 2. What about x of t plus 1? It is just right shift of this by 1 unit. So minus 1, 0 and 1. So again same. It goes here, drops back and drops down. Right? So this is 1 and this is 2. So now we need to add 2x of t1. So we'll draw 2x of t1. 2x of t plus 1. So how does this look like? So this is 2 for it now, right? And then it goes to 4, drops back to 2 and then comes to 0. So this is at minus 1, 0 and 1. Now we need to add these two signals. So let us try to add them. So we have x of t plus 2 plus 2x of t plus 1. So now what do you have? From minus 2 to minus 1, you have only this signal. Right? Here this signal is 0. So minus 2, minus 1, 0, 1. So if you add this, you will just get the x of t plus 2 portion, which is nothing but it starts at 1 and goes up to 2. So let's take 3 and 4. So then in the region from minus 1 to 0, what is there? What is happening at minus 1? This is having a value of 2 and this is having a value of 2 again. So it will go to 4. Right? But you also need to consider the limits, right? So it is like less than, not less than, equal to. So only the upper limit we have to consider. So here the upper limit is x of t plus 2, which is having value of 2 only. So 2 and here it is 0 in the lower limit. So it is only 2. And right after t minus 1, t equal to minus 1 if we see, this value is 1 and this value is again 1. So it will again be in 2. And what is happening? This is decreasing. This is going to 0. And what is happening to this? This is going to 4. So what will be its value at 0? It will go to 4. So from here, it will have a linear curve. Right? So it will have something like this. Okay. So here actually the slope is 1 and here the slope is 2. So slope I'll maybe write with a different color. 1 and 2. So it should actually be something like this. And then something steep. Okay. So and then what happens at 0? At 0, this is actually falling to 2. And this is actually in 0 only. So this again falls to 2. And from 0 to 1, there is no x of t plus 2 component. So only this 2x of t minus t plus 1 comes. And then it goes to 0. Here the slope is actually minus 2. So this is the graphical thing. If we want to get it mathematically, how do we write it? So we'll have x of t plus 2. So what is x of t plus 2? It is actually t plus 3 for 0 less than t plus 2 less than or equal to 1. This if we simplify, it will be from minus 2 to minus 1. And then we have 2 minus t minus 2. So which is nothing but minus t for 1 less than t plus 2 less than or equal to 2. So if we just subtract minus 2 everywhere, we get minus 1 to 0. And it is 0 elsewhere. And we have x of t plus 1. How do we write it? So we have t plus 1 plus 1. So t plus 2 for minus 1 less than t less than or equal to 0. And then we have 2 minus t minus 1. So which is nothing but 1 minus t for 0 less than t less than or equal to 1 and 0 elsewhere. So you can actually cross check between these two. Right? Is it the same? We have t plus 3 here and minus t from minus 1 to 0. And t plus 1 we have t plus 2 here and 1 minus t here. So it is correct. So now we will find 2 of x. So 2x of t plus 1. So what do we have? So then we'll have 2t plus 4, 2 minus 2t and 0. Now we need to add this. So we'll just check the intervals and then add it. So y of t, which is nothing but x of t plus 2 plus 2x of t plus 1. So what is this? First interval minus 2 to minus 1. We don't have corresponding counterpart in this signal. So we'll just have t plus 3 for minus 2 less than t less than or equal to minus 1. And from minus 1 to 0 we have both. So we just add 2t plus 4 minus t. We get t plus 4. For minus 1 less than t less than or equal to 0. And from 0 to 1 we have only this part, and in this signal there is no corresponding term. So we have 2 minus 2t for 0 less than t less than or equal to 1, and we have 0 elsewhere. So this should correspond to this one. So let us check that too. So t plus 3 for minus 2 to minus 1. So at minus 2 its value should be 1 and minus 1 its value should be 2. So we are getting the same, correct? And since it is linear, we can just join by a straight line. So it is just sufficient for us to check at the intervals. So minus 1, it is minus 1 plus 4, which is 3. Is it the case? So here there should be a discontinuity, right? That is what we missed. So here it should be something like this. So this slope should be again 1. Right? As you can see here also, the slope is 1. I think we missed this discontinuity because of this calculation. Here it is 2 and here it is 1. So it should be actually 3 here. Okay. So and then at 0 we have 4, which is correct. And here again it comes to 2 just after the 0 and then it goes to 0 again at 1. So this is the correct answer. So because of these discontinuities, actually the graphical method we have to be very careful. Even small mistake can cost us a lot. So I think the better thing would be to do is to go with the mathematical formulation, which seems straightforward. Okay. So we'll move on to the next question. The following are the impulse responses of continuous time LTI systems. Determine whether each system is causal and or stable. Justify your answers. So we already saw the properties of LTI systems. With just the impulse response, we can say whether the system is causal and also the stability condition we can derive. So for causality, what is the condition? H of t should be equal to 0 for t less than 0. And what about stability? The absolute integral minus infinity to infinity mod h of t dt should be less than infinity. It should be finite. So then we can say it is stable. So we'll use these two properties here. So the first system, what do we have? H of t is e power minus 4t u of t minus 2. So what about for t less than 0 stability? First let's check causality. So here for this particular case, h of t is equal to 0 for t less than 2 itself. So which implies h of t is equal to 0 for t less than 0 also. So it is causal, right? Because u of t minus 2 starts from 2 only. So u of t minus 2 is like this. Okay, so it is a causal system. Let's check for the stability. So what do you think? It is a falling exponent, right? It starts from 2. It has a value of e power minus 8, right? And it falls. So will it be absolutely integrable? Yes, it is absolutely integrable. So let's find it. So integral minus infinity to infinity h of t dt is equal to integral minus infinity to infinity e power minus 4t u of t minus 2 dt. And u of t minus 2 actually limits the integral from 2 to infinity e power minus 4t dt. The mod anyways, this is always a positive, so I am ignoring that. So this will be equal to e power minus 4t by minus 4 from 2 to infinity. So we'll get e power minus 4 into infinity minus e power minus 4 into 2 by minus 4. So this term will go to 0. We'll only be left with this term, and the minus sign will cancel. So we should get e power minus 8 by 4. As you can see, this is always less than infinity. So another check you can do here is, this integral should always be positive. So if you get any negative term here, then it means that you have made some calculation mistake. So you should always expect a positive number here. Okay, so this is the stable. Okay, so I'll take a new page. So now let us look at the B part. H of t is e power minus 6 mod t. So B minus 6 mod t. So how does this function look like? So on the positive side, it is a decaying exponent. It starts from 1 and decays. And on the negative side also, it is same, right? It is just a reflection because of this mod t. Okay, so this is the function. So we can clearly see that for h of t less than 0, for t less than 0, h of t is not equal to 0. So causality. H of t is not equal to 0 for t less than 0. So it is not causal. So the system is not causal here. What about the stability? So we need to find the absolute integral minus infinity to infinity h of t dt. So this is nothing but minus infinity to infinity e power minus 6 mod t dt. So you can compute this integral in many ways, but since it is just the reflection, I'll just write it as 2 integral of 0 to infinity e power minus 6t dt. Because it is same, the area will be going to be same on both the for t greater than 0 and t less than 0. So I'm just computing for t greater than 0 and then multiplying it by 2. So this integral is easy to compute. Minus 6, 0 to infinity. So I'll get 2 by minus 6 into e power minus 6 into infinity minus e power minus 6 into 0. So this term goes to 0 and only this term is there. The negative sign cancels and 1 and 3 also cancels. 1 and 2 and 6, right? So we get e power, and this is 1, nothing but 1. So we get it as 1 by 3, which is less than infinity. So the system is stable. So this system is not causal but stable. And the first example what we saw, it is both causal and stable. Okay, moving on. We'll next see some GATE previous year questions. So the first question, given two continuous time signals x of t equal to e power minus t and y of t equal to e power minus 2t, which x is for t greater than 0. So this is important. So they're saying it only exists for t greater than 0, which means for t less than 0, both these signals are going to be 0. The convolution z of t is equal to x of t convolving with y of t is. So we need to find the convolution. We have x of t is e power minus t u of t, right? Because of this condition. And y of t is same, e power minus 2t u of t. So we already saw many times how to convolve it graphically. So now we'll see how to do it mathematically using the formulas. So we have z of t is equal to x of t convolved with y of t, which is nothing but integral minus infinity to infinity x of tau y of t minus tau d tau. And what is x of tau? It is e power minus tau u of tau. And u of y of t minus tau is e power minus 2 into t minus tau u of t minus tau d tau. So this u of tau terms actually reduces the integral limits from 0 to infinity, because it is going to be 0 for tau less than 0. So it will be from 0 to infinity e power minus tau e power minus 2 into t minus tau u of t minus tau d tau. And what does this u of t minus tau do? It is equal to 0 for t minus tau less than 0, which implies for tau greater than t. So for tau greater than t also, this integral is going to be 0. So then what we have from 0 to t, e power minus tau, e power minus 2 into t minus tau d tau. So this is the simple integral we have. And here the t is going to be constant. So we can take it outside. So e power minus 2t, integral 0 to tau, e power minus tau into e power minus of minus, so 2 tau. So again you can add this exponents, minus 2t e power tau d tau. And you know the e power tau d tau integral is e power tau itself, limits from 0 to t. This is t. So what will this give? E power minus 2t into e power t minus 1. So then what do I have? Z of t is nothing but e power minus 2t into e power t is e power minus t minus e power minus 2t. So this is the answer. So graphically also you can try to verify. You know how to, you can choose any one signal, keep it as x of tau, and then find y of t minus tau, right? So how will x of tau look like this? Starting from 1. And t minus tau will actually look like this, right? This is t. This is also starting from 1. And then this is actually e power minus 2t. This is e power minus t. And then you need to integrate. You can see for t less than 0, y of t is going to be 0, right? So for t less than 0, you can actually observe y of t is going to be 0. So this is not the final answer. It should actually be z of t is equal to e power minus t minus e power minus 2t into u of t. So where did we miss this is nothing but here. When considering this integral, we did not consider what is the value of t, right? So even in the integral, it says from 0 to t. So we always take it t greater than 0. For t less than 0, it's anyway going to be 0. And since in the question itself, they have not stated it explicitly as u of t, z of t in the options also, we can only choose it without the u of t factor. Okay. So this was asked in GATE 2011. Okay, moving on. A cascade of 3 linear time invariant systems is causal and unstable. From this, we conclude that each system in the cascade is individually causal and unstable. At least one system is unstable and at least one system is causal. At least one system is causal and all systems are unstable. The majority are unstable and majority are causal. So these type of questions are very important in GATE. Even other questions, if you know the mathematical formula, you can just apply it and you may try to solve it. But these type of questions require you to understand the concepts. So let us see how to solve this. So we have given 3 LTI system. I'll take it as some S1, S2 and ST. So this is sitting inside one big system. So let's call it S. So observation on S, what do we have is, it is causal. The system is causal and unstable. Causal and unstable. And they're asking what information can we derive? Can we be sure about S1, S2 and S3? So for this type of questions, sufficient condition is not necessary. We need to go for necessary conditions. For example, if all three are causal and unstable, so S is also going to be causal and unstable, right? We should check if that is the only condition. So if it is given that all three are causal and unstable, then we can surely say that S is also going to be causal and unstable. But it is the other way around. They are giving S to be causal and unstable, and they are asking what can you say surely about S1, S2, S3. It may not be the case that S is causal and unstable, but all the three are necessarily causal and unstable. So it may not be case that all the three systems are causal and unstable. So we'll go for the minimal conditions. Minimal conditions required for this condition to satisfy. This is called as necessary conditions. Okay. So let's first observe what is happening. So a signal x of t is going in. Let's take, these are LTI system. So each of them has impulse response. Let's take them h1 of t, h2 of t, h3 of t, and we have finally y of t. So y of t is nothing but x of t convolved with the convolution of these three system impulse functions, right? In actuality, first it is like x of t convolved with h1 of t, and then the result is going to be convolved with h2 of t, and then the final result is going to be convolved with h3 of t. But what we have used here, we have used the associative property. So it is equivalent to saying that this system S has the impulse response of h1 of t convolved with h2 of t convolved with h3 of t. Equivalently, system S as impulse response of h1 of t convolved with h2 of t convolved with h3 of t. So now we know the property of convolution. So first let us check what makes it causal. So is all three necessary to be causal? For example, let's first observe what the convolution does. So if we take delta of t minus t naught as one of this, what happens? The other signal is going to be shifted to the left or right by t naught, correct? So in this case, it is minus t naught, so it is going to be shifting right. So if it is shifting right, then what it means, even if one of the system is like unstable, non-causal, let's say h1 of t is not equal to 0 for t less than 0, but it's equal to 0 for t less than minus 2. So it is like starting from minus 2, h1 of t. Now if h2 of t is such that it is like delta of t plus 2, then you can say their result will be actually starting from 0, right? So it is only necessary that even if the two of the systems are non-causal, the third system should compensate for that non-causal thing, right? So it is only necessary that one of the system be sufficiently causal. Okay. So now we'll check what is stability. Is it required for all the three systems to be unstable, for the entire system to be, the cascaded system to be unstable? Not necessary. Again. So I'll again open a new page. So the question is it necessary for all systems to be unstable? So let us again imagine. So H1 of t, H2 of t, H3 of t. So let's say that H1 and H2 of t are stable and only H3 of t is unstable. So if x of t is bounded, then this signal is going to be bounded. But H3 of t is going to send an unbounded signal because it is unstable. So if you see the system as a whole, you pass in a bounded signal and you got an unbounded. So system as a whole is unstable. So it is again sufficient that, or it is necessary that at least one be unstable. So more than one also can be unstable. If H of 2 also is unstable, then this output itself is going to be unbounded. Correct? And unbounded going inside a stable system will again can produce an unbounded signal. Because the stability condition is bounded input, bounded output. So if you are giving unbounded input, then the output can be expected to be unbounded as well. So for causality also we require only one of the system, at least one of the system. And for the stability also, at least one of the system, if it is unstable, the entire system is going to be unstable. So the answer is at least one of the system is unstable and at least one system is causal. So they can also ask you in a reverse way, right? So they can give cascade of three systems and then they can say one of the system is actually causal, or all three are causal, they can say, and they can say at least one of the system is unstable. Then they can ask you about what is the stability of the whole system. So these kind of questions also you can expect. Moving on. We have question number 3. So we have x1 of t is equal to u of t plus 1.5 minus u of t minus 1.5. So how does x1 of t look? So it starts from 1.5 minus 1.5 and at 1.5 it goes to 0 and the amplitude is 1. And x2 of t is shown in the figure below. Okay, this is x2 of t. For y of t equal to x1 of t convolved with x2 of t. Okay, so we want to take convolution between these two signals. And they're asking what is the area under y of t. So how do you approach this question? So if you directly take x1 of t, x2 of t and try to convolve, you're surely going to make mistake because you have some impulses here and rectangular pulse kind of thing here. So what we will do is, we'll actually break x2 of t into 3 signals. Okay, let's call it h1 of t, h2 of t, h3 of t. Okay, h1 of t is actually this delta of t plus 3. And h2 of t is this rectangular pulse, which is nothing but u of t plus 1 minus u of t minus 1. And h3 of t is, let's say, this impulse having unit value of 2, area of 2, delta of t minus 3. So now let us convolve x1 of t with h1 of t plus h2 of t plus h3 of t. So now we'll get 3 answers. Let's call them y1 of t. So this convolved with this is y1 of t, and y2 of t is this x of 1 of t convolved with h2 of t, and y3 of t is x1 of t convolved with h3 of t. So now if I have to take the integral minus infinity to infinity y of t dt, it is nothing but the area under individual things, individual signals. y3 of t dt. So with this background, we'll now find y1 of t, y2 of t, y3 of t. We'll find the separate area under them and then add them up to get the value of y of t. Okay. And I think this question was asked in GATE 2023. Okay, so now let's proceed. So first, x1 of t convolved with the h1 of t, which is nothing but h1 of t is delta of t plus 3. So we'll get x1 of t plus 3, which is nothing but left shift of this by 3 units. So we have, again, since we are taking only area, shifting, right shifting or left shifting will not change the area, right? So there also you no need to calculate all these things. So for now, I'll just do it for your sake. So it will be minus 1.5 to minus 4.5, amplitude of 1. So the base is 3. This is going to be y1 of t. So the area under y1 of t is 3 into 1, which is 3. Right? And what about y2 of t? y3 of t is easy to compute, right? So we'll first take that. So this will give you 2 into x1 of t minus 3. So this is right shift. So what do I have? It will actually right shifting by 3 units. So it will start from 1.5 and go up to 4.5 and its amplitude is actually increased to 2. So what is the area here? So this is 3 into 2. This is 3 into 2. It's still just a rectangle, right? So it will be 6. Now let us find y3 of t. y2 of t, sorry. This is y3. Let's find y2 of t. So we have, this is h2 of t, minus 1 to 1. And we have x1 of t, which is minus 1.5 to 1.5. So in the lectures, actually we saw a derivation for these kind of signals, right? When we are integrating two rectangular pulses. So it will actually start from this plus this, right? So if it is AB, A minus A to A, and this is from minus B to B, we'll actually start with minus of A plus B. And then the second signal will be minus of A minus B, or whichever is greater. Here B is greater, so we'll have B minus A. Then we'll have B minus A, and then we'll have A plus B or B plus A. Okay, so here it will be minus 1.5, minus of 1.5 plus 1, which is minus 2.5. And the other limit will be minus of 1.5 minus 1, which is 0.5. And then this will be just a reflection of that. So from here to here it will increase, and up to what value it will go? It will be 2 into the smallest of these two. So it will be 2A. Here A is 1, right? So it will be 2. So it will stay at 2 and it will again fall to 0. So this is the convolution. You can also compute it easily. So x of tau will be this thing, and h2 of tau, t minus tau will actually shift the reflected one, time reversed one, and shifted by t. So if you just try to bring the window, like it will be like this, t minus 1 or t plus 1 to t minus 1, right? So you can bring this window by varying t from minus infinity to infinity. So up till this point, t plus 1 less than minus 1.5, it is going to be 0. And above that, this is minus 2.5. So for t greater than minus 2.5, it is going to get integrated. And it will slowly increase. And once this entire window comes inside this x of t, the value is not going to change. So it is being constant for some while. And again, when it is leaving, again the area decreases. The area under the convolution decreases. Right? So now this is y3, y2 of t, and we need to find the area. So we can just divide this into 2 right angle triangle and 1 rectangle. So what is the area of this thing? This half into this base is 2, height is 2, 2 into 2, which is 1. I'll remove this. And this rectangle, what is the area? 2 into 1, which is 2. And here, this, since these two are symmetrical, this area will be 1. So this total area is 4. So now we have all the areas. 3 plus 6 plus 4. Sorry, this is half into 2 into 2, right? So this is 2 and 2. So this area is 6. So what do we have? The total area 6 plus 6 plus 3. So integral minus infinity to infinity y of t dt is 6 plus 6 plus 3, which is nothing but 15. So you have to be quick in all these calculations so that you can save time in the GATE exam. So definitely it will take less time for you if you already know this, if you already worked with these type of convolutions. So that is where practice is important. Okay everyone, I hope you enjoyed today's lecture. Stay tuned for more. Please leave down below your comments. Take care. Bye.